Welcome to Unit 3, Day 10, Part 2. We just solved a bunch of equations that look possibly like this, or maybe with a quadratic formula. And in all of these equations, our goal was to find the roots, but it turned out that the parabola, it did have roots, except that they were kind of weird roots, and they turned out to be imaginary numbers. So I would imagine you're probably wondering, what does this really mean? Well, as usual, in order to better understand this, we're going to go back to what the graph looks like. And I'm wondering, what do we already know about the graph of this function? Well, we talked about how it's in vertex form, which means that I know the vertex, because the vertex is h and k, and that's -1 and -8. We also know that this parabola is facing down, and that's because the a value is a negative number, which means that this vertex point, it's going to be a maximum. So I wonder whether we could sketch a graph of this parabola and to try and understand really what these roots are talking about. So I'm going to just make a rough graph right here. It's not perfect, but that's fine. And if I were to plot this vertex point, I would go left 1, and then I would go down 8. Which is going to be all the way down here. And then I'm going to draw a downward-facing parabola, which looks something like that. And you remember that roots are normally the place where it crosses the x-axis, and yet there's something funny about this parabola, which is that it doesn't. Let's take a look at another before we discuss really what that means. It's kind of curious. Here's the second example that we talked about. And this one's not in vertex form, but I can still find the vertex. It's just going to take an extra step. I have A, B, and C, not H and K here. And so to find the vertex, I'll use the formula that you have memorized, which is H equals -B over 2A. I plug it in, the -2 becomes a +2. And then we have 2 times 1 on the bottom, and 2 over 2 is 1. So that's my h value, which is the x-coordinate of the vertex. In order to find the y-coordinate of the vertex, I go back to my original function, and I plug in 1 for x in both of these spots. So we get 1 squared minus 2 times 1 plus 8, which is equal to 1 minus 2 plus 8, which is +7. And that's the y-coordinate of my vertex. I can also know that this parabola is facing up because the a value is +1, which means that this vertex point is a minimum. And if I were to sketch this one, there are my axes, and I'd find the vertex point, which is 1, and then 1, 2, 3, 4, 5, 6, 7. And even though this parabola is facing up, it's kind of similar to the one above. Well, I'm sure you've made a pretty smart conclusion, so I'll jump to the chase here. The truth is that not all quadratic formulas, not all parabolas have 2 roots. And there's something called the discriminant rule that helps us figure out whether or not the parabola will have 2 roots. The discriminant, you probably remember from Algebra 1, is this formula, b squared minus 4ac. And you'll recognize that it's just the part from the inside of the quadratic function. Notice that we don't use the square root here. The quadratic formula has a square root, but we don't use that when we talk about the discriminant. It's just the b squared minus 4ac. So a normal parabola, the ones that we're used to, have 2 roots. And they look sometimes like this, or sometimes they face down, but in either case, there are 2 points where they cross the x-axis. So here's the rule. Looking at this discriminant, if the discriminant, b squared minus 4ac, is a positive number, and the way I'm going to write that is greater than 1. If you need to make a note to yourself, all this is saying is that this is a positive number. Then the function f of x has 2 real roots. 2 roots that are different and that are real numbers. Now there is another possibility, or actually 2 other possibilities. Sometimes the parabola might be sitting right on the x-axis. In other words, the vertex is touching the x-axis. And for both of these functions, they just have one root because there's only one x-intercept. And in this case, what you will find is that the discriminant b squared minus 4ac actually equals 0. And that's why you may solve it out and get two equations, but it'll turn out that both of those equations have the same number. And if this is what happens, then the function f of x has one real root. And you've probably guessed the last possibility, which is that f of x may have no real roots, which is the same thing as saying it has roots that are imaginary numbers. And what we just saw when we looked at those first two examples is that this is when the parabola doesn't cross the x-axis. And it could be going up or it could be going down, either way. Both of these. And what you'll find is that if you calculate the discriminant, b squared minus 4ac, this expression will turn out to be a negative number. In other words, it's less than 0. So what we can do is we can use this little trick to predict whether or not my parabola is going to have any roots. Take a look at the examples here. We'll pause the video for a second so you can calculate the discriminant of each of these functions, and then we'll look at what they mean. Here we go. When I calculated the first discriminant, it came out to be a positive number, which means this function has two real roots. The second discriminant equals 0, which means this function has one real root. And the last is an example of a negative discriminant, in other words, a function with no real roots. There are 3 practice problems for you at the bottom. If you haven't already completed them, we'll pause and do that now. Otherwise, here are the answers. Your homework assignment tonight is on the back of your packet. It is a quiz review guide. You should complete these problems on a separate piece of paper. You will not have room to do them on the first, and I will be posting an answer key so that you can use it to study for tomorrow's quiz. Have a great day.